Understanding fractions. Last week we focused on place value and number sense with whole numbers. This week we are going to focus on fractions. Before we start using operations with fractions, let's review the basic understandings of what a fraction represents. A fraction is a number. It just looks different than a whole number. A fraction represents part of a whole. A fraction also is a division problem written differently. You are dividing something whole into parts of that whole. So let's refresh our math vocabulary really quick. First, let's talk about the numerator. The numerator is the top number in the fraction. It represents the part or parts of your whole amount. Next is the denominator. This is the bottom number in the fraction. It represents the total number of parts you need to make one whole. So let's look at fractions on a number line. This number line goes from 0 to 2. I am using the benchmark fraction 1/2 to divide my whole numbers. I've used pizza because, well, we can all relate to pizza. As you can see on my number line, I have divided each of my whole pizzas into 2 parts. So if we stop and take a look at this, let's get some colors here. So here, from 0 to 1, this is one whole pizza. And as you can see right down here, I've said I have one whole pizza at this point. Then, if you go back over here, let's change our color again. From 1 to 2 makes another whole pizza. So, here you can see at the end of my number line, I now have 2 whole pizzas. So, as you can see on my number line where I've divided the pizza into halves, or into 2 parts, I need 2 parts or 2 halves, or 2 halves as a fraction, to make one whole pizza. So let's switch our colors again. So I need 1. That makes 1 part because that's 1/2. 2, there's 2 parts in order to create that whole pizza. So I needed 2 parts or 2 halves to make one whole pizza. So how many parts would I need to make 2 whole pizzas? Well, again, if I start at my 1 and I go from 1 to the half mark, which would represent 1 and 1/2. And then again, from the 1/2 mark to the 2, well, now you can see I would need 1, 2, 3, 4 parts to make 2 whole pizzas. And that would look like 4 halves or 4 halves as a fraction. That's an improper fraction because the numerator is greater than the denominator. Okay, so this is a very simple example of fractions. However, you can apply this concept anytime you are working with fractions from now on. All right, so let's go on to page 2. And now we're going to be working with making equivalent fractions. So now let's focus on creating equivalent fractions. First, let's talk about the word equivalent. Simply put, it means equal. So when we talk about equivalent fractions, what we are saying is that although the fractions look different, they equal the same part of the whole. So look at our number line again, but in two different ways. First, we have our number line from earlier, which is divided into halves. So as you can see, I'll bring it up a little closer. We have our number line. We're starting at 0, going to 1 and then 2, and we have divided it into halves. Next, let's look at the same number line, but we are dividing it into fourths. So now, if we look at this number line, we still have our 0, 1, and 2. We still have our 1/2 mark between 0 and 1 and between 1 and 2. But now we also have our 1/4 marks. So here we have 1/4. Here is 2/4, 3/4. This would technically be 4/4 or 1/2. And then we start back over again, but now we would say 1 and 1/4, 1 and 2/4, 1 and 3/4, or 2 whole, which would look like 8/4. Or you could say 4/4 again if you're just talking about a whole. So the number line is spaced the same, but now it's also been divided into fourths. So now when we look at the number line, how many parts do we need to make one whole pizza? So this time we would need, let's go back and let's get our pretty color. We would need 1, let me make that a little bit bigger so you can see it, 2, 3, 4 parts to make one whole pizza. So using our fourths, how many parts would we need to make 1/2 of a pizza? Well, we can look up here and see we needed 1, 2 parts to be able to make half of a pizza. Now let's look at what I just said, but in a mathematical way. So, we see that 4/4 is equal to 1 whole, just as I showed you on the number line, and 2/4 is equivalent to 1/2. We also just saw that on the number line. So using 1/4 markers on the number line above, how many jumps do we have to make to go from 0 to 1/2? Well, let's see, which we did it, but we'll do it again. So I'm going to get my red, go 1, 2. We had to make 2 jumps to go from 0 pizza to 1/2 of a pizza. So we had to move 2 times. When creating equivalent fractions using math, we have to multiply or times both the numerator and denominator by the same number. And here's what it looks like. So you have, switch back over to black, you have your fraction, 1/2. You're multiplying your numerator times 2, and you're multiplying your denominator times 2. 1 times 2 is 2. 2 times 2 is 4. So in this case, I multiply both the numerator 1 and the denominator 2 by the number 2 because that's how many times I jumped to get from 0 to 1/2. Therefore, 1/2 and 2/4 are equivalent fractions. All right, so let's take a look at this visually, using pizza, of course. So as you can see, my first pizza is divided in half. So I had a whole pizza. I had one whole pizza right here. And I divided it into 2 halves. So my 2 halves equal 1 whole pizza. Now, if we look down to the next image, my next image, I divided my pizza into 4ths. So again, I have the same whole pizza, but this time I did 1, 2, 3, 4. So I split it into 4ths. So we can see that I need 4 of my 4 pieces, or 4/4, in order to have 1 whole pizza. But I can also compare my first 2 images by saying, well, how many 1/4 pieces do I need to make up 1/2 of my pizza at the top? So, if we color, and let's go with pink. So, if we say 1/2 of my pizza, color, 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 color. All right, so there's 1/2 of my pizza. How many 4ths do I need to be equivalent to 1/2? I need to color in 1, 2 of my 4 pieces, color, 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 to be able to make the same amount, or to have the same amount that I had in 1/2. So, right now you can see visually that 1/2 is equivalent to 2/4. These are equivalent fractions. Now, let's scroll down a little bit more and let's look at my pizza down here. Well, now you can see, hopefully, I'll make it a little bigger here for a minute. You can see that my pizza has been cut into 8ths. So I had 8 slices that make 1 whole pizza. So again, I started with a whole, and I cut it into 1/8 slices. So, first of all, I know I would need 8/8 to equal 1 whole pizza. But I also want to see how many 8ths do I need to be equivalent to the 2 1/4 pieces that make up half of my pizza. Well, if we want it to be equal, and it will be, we would have to take out 4 1/8 slices, and I'm going to color the other side this time. I'm going to do 4 1/8 slices in order to have an amount of pizza that is equivalent to my 2/4 in my middle pizza or my 1/2 in my top pizza. So now you can also say, oops, don't want to do that. 2/4 is equivalent to 4/8. 1/2 is also equivalent to 4/8. So all three of my fractions, even though they had different denominators, one had the denominator 2, one had the denominator 4, and finally my last one had the denominator of 8, even though they had different denominators, we can see that those fractions are equivalent because they take the same amount of space. It takes the same amount in order to equal half of a pizza. All right, finally, we're going to focus on comparing fractions. Not finally, I lied. We are going to do comparing fractions, though. So comparing fractions is very similar to comparing whole numbers. The difference is that you compare the numerators of the two fractions. So for example, 1/7 and 5/7. It's easy to see that 5/7 is greater than 1/7 because we know that 5 is greater than 1. So you can see your 5 here, your 1 here. So we can see the denominators are equal. They're both 7. So we can say absolutely that 5/7 is greater than 1/7, or 1/7 is less than 5/7. Now you also want to make sure that your denominators are the same in the fractions you are comparing. Otherwise, you are going to have a much more challenging time deciding which fraction has the greatest value. So for example, we have 1/8 and 1/4. Now by looking at the two fractions, many would want to say that 1/8 is the greater fraction because 8 is greater than 4. But remember, when we compare the numerators of a fraction, not the denominators. So, you have a couple of options. You can either make the fractions equivalent by multiplying both the numerator and the denominator of 1/4 times 2, or you can create a visual model like the one below. So very quickly, before we get into our visual fraction model, I'm going to show you what I mean when I say multiplying times 2. Now, I look and I see I have a denominator of 8 and a denominator of 4. Now, I'm going to ask myself, can I make this 4 an 8? Well, the answer is yes, I can, because I can multiply 4 times 2, and that equals 8. Now, whatever I do to the denominator, I have to do the same thing to the numerator when I'm creating equivalent fractions. So if I multiplied my denominator times 2, that means I'm also going to have to multiply my numerator times 2. And 1 times 2 equals 2. Now, I can leave 1/8 the same because now I have 1/8 and 2/8. My denominators are now the same, and so I can compare these fractions. I'm going to erase my little line here. And I'm going to say now, what's greater, 1 or 2? Well, 2 is greater, so therefore 1/8 is less than, 1/8 is less than 2/8. 2/8 is the greater fraction. Now let's look at that in a visual fraction model. So down here, you can see that I created a visual fraction model for 1/4, and I created a visual fraction model for 1/8. Now, remember, when you're creating a visual fraction model, you have to make your two models the same size. So in this case, both of my fraction models start here, and both of my fraction models end here. They're the same length, they're the same size, but in each of them I've divided them differently to show 1/4. So I have 1, 2, 3, 4 boxes total. 1 is colored in. And down here I have, let's get a different color for this one. Let's go blue. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 parts, but only 1 is colored in, and that represents 1/8. Now, if you compare 1/4 to 1/8, let's do this real quick. Let's erase these marks on either end because we don't really need those. Now, let's compare. So if I were to draw a straight line, and I'm going to use my grid paper here to help me too, and you always in math use grid paper. It makes it so much easier. I'm going to start with my 1/4 model, and I'm going to draw a line all the way down, and I'm going to keep following that same line straight down through my 1/8 model. Now, as you can see, visually, my 1/4 is bigger. I have more area colored in my 1/4 than my 1/8. It would take 2/8 to be colored in, so I'd have to color in the second one here. I'm going to color it in. It would take me coloring in both of these parts to make them equal. So now you can see visually that 1/4 is greater than 2/8, and 1/4 is equivalent to 2/8, which is what we had created up here earlier using our math, using our equivalent fractions. So a visual fraction model is a way to just help you to see visually which fraction is greater. But make sure that your visual fraction models are the same size. If you create something like this, so here's how I'm going to create my 1, 2, 3, 4, but then I'm going to use my 8. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. For your eighths, you can't compare. You have a smaller box, so obviously it looks like 1/8 and 1/4 are equivalent because they're the same size, but they're not. They're really not. So that's why you want to make sure that when you draw your visual fraction model, that both models are the same size, just like I did here. Again, I'll kind of point it out one more time. They take up the same amount of space. It's just that they're divided differently. All right. So now finally, really finally, we're going to move on to decomposing fractions. So we're going to just do a quick review on decomposing fractions because it's pretty simple. So the word decompose means to break down into pieces. So you will hear this word in science a lot as you get older. But in math, we are using it to break apart or break down a fraction into its pieces or parts. Okay? So my example is, how can you decompose the fraction 5/6? Well, there are actually many ways to decompose this fraction. So you can break it down. 5/6 is equal to 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. So you noticed I did 1, 2, 3, 4, 5 1/6 and added those ones together to make 5/6. I could also do, for number 2, 5/6 equals 3/6 plus 2/6 because 3 plus 2 equals 5. All right, next one, number 3, 5/6 equals 4/6 plus 1/6 because 4 plus 1 equals 5. Number 4, 5/6 equals 3/6 plus 1/6 plus 1/6. And finally, 5/6 equals 1/6 plus 1/6 plus 1/6 plus 2/6. All right, so really breaking down or decomposing fractions is going to start to benefit you more as you're looking at just understanding the overall fraction. But it is something good to know how to do. All right, so this concludes our lesson for this week. You now have all the tools you need to be able to create equivalent fractions, compare fractions, and decompose fractions. Next, you'll work on the practice activity on Converge under Week 2, Understanding Fractions. I've also put some games in this section so you can apply your skills in a fun way. So a couple of notes before we wrap it up for this week. Please remember the following. I will have a face-to-face session this week during Black and Gold for those needing extra help. It will be on Wednesday, June 21st at 1:30 p.m. It's going to last about maybe 30 to 45 minutes depending on your needs. If you plan to stay with me for help, please email me no later than Tuesday, June 20th. I need to be able to know who is coming to meet with me so that I can make sure you are there with me before I take you to a classroom to work. Also, make sure to complete the exit slip for week 2. I will have it in I will have it in on Converge on Friday. Sorry, my own typing messed me up. All right, so guys, good luck. Have a great week. If you have any questions about this after you complete the practice activity, email me. Let me know that you want to stay on Wednesday. And I'm more than happy to do just, a little face-to-face meeting so that we can talk more about either last week's place value or this week's understanding fractions. So anyway, guys, take care. Have a great week, and we will see you later. Take care.